Envision where the stars stop shimmering and cosmic systems choose to call it stops. What mysteries could prowl past this recently discovered limit? Are we on the edge of unwinding the best infinite secret? Or is this simply the start of an entirely different section in our vast experience? Well, it appears it is. Webb cases have tracked down the finish of room itself. Yes, you heard it right. The last outskirts probably won't be so boundless later. Everything except, hang on a sec. How could space have an end? Wasn't it expected to continue forever? Okay, we should find out what's, as a matter of fact, happening. When I heard this news for the first time, I was completely siphoned up to uncover one of the numerous secrets of the universe. The James Webb Space Telescope has been doing exactly that, and it's flipping how we might interpret the universe on its head. In only 12 hours of perception, this wonder showed us things that left us gazing wide-eyed and scratching our heads. Okay, we should envision together how huge the universe really is. Recently, let your creative mind roam free and think as far as your psyche can go, coming to the very edge of room. Presently, we should figure out exactly how much the James Webb Space Telescope can really see out there. The genuine reality is astonishing. So, jump on board our non-existent superfast spaceship and let's not burn through any additional time. Now, we head to the edge of our planetary group, passing planets like Mars, Jupiter, Saturn, Uranus, and Neptune. We've covered 100 cosmic units, and here we are at the heliosphere limit. Past this point, we enter interstellar space, where Explorer 1 and 2 have wandered. Now we approach the Oort cloud, a mass of space rocks 200,000 galactic units away from Earth. It's meager, and we can without any problem explore through the space rocks, entering complete murkiness. Zooming past stars and planets, we arrive at the edge of our universe within the space of minutes. No more berry twist, just brilliant specks of different cosmic systems planning our course. We understand our universe isn't endless. It has a limit 10 billion light years away, and there may be different universes. The first supervoid, a billion light years wide, could be proof of a crash with another universe. Yet, how would we get to these different universes? Dark openings may be the key. They're puzzling, twisting both reality. A few researchers even propose the presence of white openings, the inverse of dark openings. The thought is that these could prompt different universes. Recollect the Big Bang in 2006? That strange explosion of energy might have been a child white opening, obliterated nearly promptly. Now we should discuss the Andromeda Galaxy, traveling our direction at 68 kilometers each second. Don't panic, it won't crash tomorrow. Yet when it does, things get interesting. We could observe a heavenly impact, or maybe our nearby planet group gets tossed into dim space like a tennis ball delivered on a rope. Fast forward, the worlds blend, and the dark openings at their focuses start a dance. They eventually converge into a supermassive dark opening, delivering energy and a functioning cosmic core apparent for a large number of light years. Then we have the South Pole Wall, 500 million light years away, containing a quadrillion stars. There's also the Hercules Corona Borealis Great Wall, a flat superstructure 10 billion light years wide. And remember the enormous quasar group, 4 billion light years across, 6.1 million times heavier than our sun. Then there's the detectable universe, more than 500 billion systems, each with billions of stars. However, wait, there's a void called the Eridas supervoid, or the cold spot, 1 billion light years wide. Some believe it's a consequence of a crash of universes, two air pockets touching and tearing material away. Now picture the universe as a monster air pocket, and there may be endless air pockets, wormholes, or gateways inside dark openings. These could be shortcuts between these universes. Imagine collapsing a piece of paper to connect 2 points without crossing the entire sheet. That's the thought. Talking about dark openings. Falling into one could be survivable if its monstrous gravity's effect increases continuously, avoiding the feared spaghettification. Who knows, surviving a fall could land you in an alternate universe with different physics. But for now, it's just a wild hypothesis. So imagine you're out on a starry evening, looking up at the stars. Could appear as though they're fanned out evenly, right? Well, it seems not the case. All those stars are part of something gigantic, a tremendous astronomical web connecting worlds across the universe. Space experts using the James Webb Space Telescope have just accidentally found what could be the oldest strand of this vast web of all time. Found recently, let me break it down for you. In 2 papers published in the astrophysical journal Letters, researchers give everything away on this mind-boggling find. They used data from the James Webb Space Telescope to reveal a titanic ringlet comprised of 10 tightly packed worlds. It extends over an incredible 3 million light-years. Shani Danieli, an astronomer from the University of Arizona and part of the investigation team, couldn't contain his excitement, saying, "I was astonished by how long and how tight this fiber is. I expected to find something, but I didn't expect such a long, clearly slight structure. It's like accidentally finding a secret old treasure in the vast vault." This ancient fiber of gas and stars dates all the way back to just 830 million years after the Big Bang. That's essentially the universe's child years. And guess what's anchoring this monster string? A very massive dark opening. Of course, this dark opening isn't just any ordinary one. It's an incredibly bright celestial object that behaves like the anchor for this astronomical design. The team behind this marvelous discovery is part of the TRI project. What's TRI? Well, it stands for Spectroscopic Survey of One-Sided Coronas in the Reionization Period. Fancy name, right? Their mission is to figure out how the earliest dark openings affected the development of galaxies. And guess what led them to this ancient fiber? One of the 5 early universe quasars they had their eyes on. Fan Wang, an astrophysicist from the University of Arizona and the mind behind this, is really excited. He exclaimed, "This is one of the earliest filamentary structures that people have ever seen associated with a distant quasar. It's like they accidentally found an invaluable treasure map, revealing secrets of the universe's early days." Now here's where it gets fascinating. The researchers believe dark openings played a crucial role in shaping this enormous web. Imagine dark openings behaving like magnets, drawing matter along with their gravity. But wait, they also periodically throw stuff far away with what they call galactic winds. Gravity is the glue that keeps these strands of stars and dust connected, even as the galactic winds try to pull them across the vastness of the universe. So what's the fate of this ancient fiber? Well, the specialists have a cool thought. They believe that over time, this astronomical string will gather into a cluster of galaxies, like the Coma Cluster, which is around 330 million light-years away from us. It's like watching the universe grow and create its own magnificent masterpiece over thousands of years. When the Webb telescope focused its mirrors on a patch of sky, it saw way more light and many more galaxies than expected. Not just any galaxies, but large, brilliant ones. Now researchers are scratching their heads and coming up with various possibilities to explain this cosmic mystery. They're like forks in the road, each leading to new questions and understandings. Choice 1. Perhaps stars and galaxies formed differently and more efficiently in the early universe. Imagine a dim room without many stars and galaxies, making it easier for them to form quickly. A surprising but not an absolute change from what we know. Choice 2. What if the brightness isn't from stars, but from very massive dark openings? That's right, instead of a universe full of stars, we may be looking at galaxies illuminated by these mysterious dark openings. However, if true, it challenges what we thought we knew about the number of these beasts existing in the early universe. Choice 3. The most extreme possibility is that our understanding of the universe's recipe book, called cosmology, is incomplete. It's a bit radical, but it could shake up our comprehension of everything. Choice 4. And then there's the special case option. There may be some unknown part of the universe that we haven't even considered. Now, why does all of this matter? Well, it's about finding our place in the universe and understanding the story of how we got here. If we're missing something crucial in this story, solving a puzzle is like trying to do it without all the pieces. The more we dive into this mystery, the more questions arise. Recent discoveries from the James Webb Space Telescope have given us a reality check about the size of the universe. We could have been off track. Researchers dropped a sensation in a recent paper, claiming that the telescope got glimpses of stuff only 120 million years after the Big Bang, if the Big Bang even occurred. Besides, it challenges the very foundation of the standard cosmological model. The universe probably isn't as old as we naturally thought. And what Einstein would call it being vastly old turns out to have come up short. Our instincts have been playing tricks on us, and we're starting to figure out we don't really understand what's out there. The James Webb Telescope looks into space trying to see far, yet it can reach around 46.5 billion light-years away. We call that the Hubble sweep or Hubble circle. And guess what? The most distant galaxy ever found by the telescope, the maximum 0647 JD galaxy, lived only 450 million years after the Big Bang and is still within this Hubble circle. Now, our universe is like a balloon that's continually getting bigger. Not only is it expanding, but it's advancing quickly in its expansion. Beyond the Hubble circle, the universe is loosening up faster than the speed of light. But the Hubble circle won't continue to grow forever. There's a grandiose horizon limit, an extravagant term for the discernible universe. Imagine a tremendous non-existent shell around us, 93 billion light-years wide. That is our limit, the farthest we can see. Anything past that? Sorry, not visible. But how big is the whole universe outside our vast shell? Well, we don't know. There are competing hypotheses and math keeps us honest. Some say it might be infinite, while others toss around numbers like the universe being 10 to the power of a billion times bigger than what we can see. Yet, the distribution of matter in the universe and the even spread of temperature in the cosmic microwave background radiation suggests that our universe may be infinite. Yes, you heard it right. Asterisk asterisk infinite asterisk asterisk. Mind blown already? When we look into the infinity of space, we're not just looking at distant galaxies. We're actually looking back in time. Those galaxies we see near the Hubble circle, they're not depictions of the present. They're like cosmic fossils, leftovers of a past era, billions of years ago. It's like having a time machine, except instead of traveling, we're just looking very far back. According to our cosmological model, around 13.8 billion years ago, the entire observable universe crunched into a little point called the singularity. Well, that's the standard story if the universe is balance limited. But if it's infinite, which it sort of seems to be, then the Big Bang wasn't just a local event. It happened everywhere, even beyond what we can see. The first galaxies didn't spring up in a specific part of space. They were the universe's big opening act, happening everywhere, even beyond what we can see. The inevitable question, though, is what triggered it all? What or who made everything from nothing? Einstein was initially against the idea of a Big Bang. He preferred the idea of a steady-state universe that had been cooling forever. However, conditions have a way of changing minds, and eventually he jumped on the Big Bang bandwagon. Still, some people, including our friendly scientists, describe this cosmic story as not the beginning, but more like a universal birth announcement. Just when we thought we had the universe's story arranged, the James Webb Space Telescope came and knocked our socks off. It recently stumbled upon F200b45, a galaxy that could change infinite history. This galaxy is so distant that, if confirmed, it would challenge our comfortable 13.8 billion-year-old universe account. Webb has tracked down galaxies that shouldn't exist. I'm talking about enormous galaxies appearing just a few million years after the Big Bang, a cosmic speedrun that challenges our current understanding. Even more stunning, the telescope spotted early dark openings, just 700 million years after the Big Bang. Dark openings combining left and right, potentially explaining how these cosmic vacuum cleaners grew in their infancy. These discoveries are causing some astronomical mayhem in the realm of cosmology. The universe may be older than we thought, or it may not have had a beginning at all. Imagine if our universe is like that favorite storybook that never had a first page. It's always been there, just unfolding through various chapters as we peer further into space. The idea of an infinite universe is beginning to make sense. If the universe seems infinite in size, what's the big deal with it being infinite in age? Perhaps the Big Bang was just an unexpected event, not the initial scene. Yet it's a big maybe, and we need more exploration. Does this timeless universe energy jive with our ongoing scientific efforts? Can it explain the intricate dance of events during the Big Bang? There may be around 2 trillion galaxies out there, but cosmologists are scratching their heads. wondering how much more of the universe is out there beyond what they can see. Virginia Trimble, an astronomer from the University of California, puts it like this: the universe has always been slightly bigger than whatever we can see. It's like the universe is playing hide and seek, and we're desperately trying to figure out where it's hiding. John Mather, a Nobel Prize-winning cosmologist from NASA, breaks it down. We've already seen as far as you could possibly imagine. At the very edge, we get a brief glimpse of the luminosity from the Big Bang. But this isn't as far as it goes. The universe continues going, and we may never fully know. As they continue searching for answers, cosmologists have taken a leaf from the old Greek mathematician Eratosthenes' book. They're trying to figure out the shape of the universe to solve the mystery. Think of it like determining whether the universe is a giant saddle, an immense circle, or a flat sheet. Now, the saddle-shaped idea doesn't have many fans, but a round universe feels familiar to us. Einstein named this model a limited yet unbounded universe. However, in the late 1980s, observations of cosmic microwave background radiation showed that space is flat, with no bend. As John Mather describes it, it's like an infinite sheet of paper. This evenness suggests that one could travel endlessly in any direction, encountering galaxies endlessly. While this fits well with current galactic theories, it raises questions about the universe's limit. Virginia Trimble notes the difficulty in determining whether the universe is infinite, comparing it to sorting out whether or not a pizza is infinite or if it has an edge. This leads to an investigation of the universe's edge and what lies beyond, considering various possibilities, including the chance of a multiverse. Some theories suggest the universe could be a bubble in an expanding multiverse, potentially with an edge and different physical laws on the other side. Space experts look for a hypothetical model to determine the universe's infinity, similar to the prediction of particles like the Higgs boson before their discovery. Engaging the public, the cosmic story invites interest and exploration.